Here we go. Unit 8 is electricity and magnetism, and this is the first lesson. The guided notes are not available yet, but they will be coming soon. So please make sure you kind of know how to do notes now that you're looking for the blue highlighted words. Pause the recording and make sure you add them to your science notebook. The Hoover Dam in Nevada, an engineering marvel, is one of the largest projects ever built by humans. At the foot of the dam, a huge power plant provides electricity to much of the western United States. To understand how the power plant works, you need to know about two forces, electricity and magnetism. You will learn about these forces in this unit. So, have you ever seen a flash of lightning and counted the seconds waiting for the thunder? Lightning occurs when electrical energy is transferred from the sky to the ground. Something similar happens when you walk across a carpet and then feel a small shock as you touch the TV. Electric charges, which can be found in all materials, cause both lightning and static electricity. Let's take a look at electric charges, what they are, and how you can observe their effects. So on this page, you have an explorer, seeing the effects of an electric charges. If you have long hair, you may have combed it and then watched it stick out in all directions. At the same time, your comb may have acted strangely, attracting small pieces of paper or lint. These responses occur because electric charges have built up as the comb runs through your hair. Take a look at the images in the on-screen gallery. Each one shows an example of static electricity. This is styrofoam clinging to a balloon. Then read on to find out how these phenomena occur. I have this happen all the time when it comes out of my dryer. So, static electricity charges come from specific parts of an atom. Every atom has a nucleus containing positively charged protons. We learned this in the fall. This nucleus is surrounded by negatively charged electrons. A positive charge is represented by a plus sign, and a negative charge, just like in math, is represented by a minus sign. Electric charges always act in a certain way. Opposite charges attract each other, and like charges repel each other. If a positively charged object is near a negatively charged object, they will pull toward each other. If two positively charged objects are near each other, they will push away from each other. What do you think happens when two negatively charged objects are near each other? The term force of attraction, yes, this is one of your words, describes the force that pulls opposite electric charges together. It is also the force that keeps negatively charged electrons around the positively charged nucleus of an atom. So just like the two positives, the two negatives would also push apart. Electrons are particles with a negative charge, and protons have a positive charge. Just as you add numbers in math, you can add charges. Negative charges cancel out positive ones. If you have equal numbers of each charge, the combination is neutral. It has no charge. Therefore, atoms with the same number of protons and electrons are electrically neutral. They have no charge. An atom that has an unequal number of protons and electrons is a charged particle called an ion. Now, this should be a review for many of you. We learned about ions. The charge of an ion is equal to the number of protons minus the number of electrons. If an ion has more protons than electrons, it has a positive charge. If it has more electrons than protons, it has a negative charge. We're going to take a look at each of these to see what happens to the charge when sodium atom loses an electron. So it shed off one of its valence electrons. Hopefully some of this is sinking in from the fall. There you go. Down here at the bottom, you can see that chlorine has 17 and 18, so has a net charge of -1. Here, the chlorine atom has 17 and 17 and a neutral charge. And here, this was the original sodium that lost the electron and sent it over here. See it? Go on to your own lesson to check it out. Everyday objects can also have electric charges. In today's class, we'll be going to a lab at the end and doing a lab with the same kind of materials here. This occurs when the atoms of the object gain or lose electrons. When a balloon is rubbed with a wool cloth, electrons move from atoms in the cloth to atoms in the balloon. This causes the balloon to have a net negative charge because it has more electrons than protons. The wall is neutral. As the balloon gets closer, its negative charge repels electrons on the nearby part of the wall. By pushing the electrons in the wall a little farther away and pulling the protons a little closer, the balloon sticks to the wall. The force of attraction between the opposite charges keeps the balloon on the wall. If you rub two balloons with wool cloth and held them close together, what do you think would happen? What happens when they have the same charge, either both positive or both negative? And the answer would be they would repel each other because they would both have a negative charge. It's a fun little interactive. A particle, now this is important. Electric fields, make sure you write this definition. A particle that has an electric charge affects the space around it. The electric influence around a charge is called its electric field. Stop the recording, write the definition. The effect of a particle's electric field on other objects depends on the object's distance from the charge. The field is stronger at a point close to the charge than it is at a point far away. So the effect of the two charges on one another decreases as the charges move farther apart. Now the little lab in this lesson is amazing, and it will show you how that electric field works if you take the opportunity to do it. So let's move on here. The force between two charges depends on the amount of charge and the distance between them. The amount of the charge is shown by the number of plus signs. If the amount of charge increases, the force of attraction or repulsion between them increases. If the distance between the charges increases, the force between the charges decreases. Just like with magnets, the closer they are together, the more apt they are to snap together, whereas if they're farther apart, that magnetic field is not as strong. This applies to both attraction and repulsion. Think about the two balloons that are electrically charged. To get two charged balloons to repel each other, they need to be near each other. Why won't they repel each other if they are far apart? Why wouldn't they repel each other if they were far apart? They won't repel each other because the electric field each charged balloon produces will decrease with the greater distance. So where do the electrons go? Let's take another look at the examples we saw earlier of static electricity. Why are the objects attracted to or repelled by one another? When you comb your hair with a plastic comb, electrons are transferred from your hair to the comb, leaving your hair with a positive charge. Each charged strand of hair is repelled by the other strands, so they move apart. The girl in the picture has her hand on an even stronger source of static electricity, the Van de Graaff generator. Her hair stands straight out. If the tissue paper and the styrofoam pieces are neutral, why are they sticking to the comb and to the balloon? That's because the tissue paper is neutral. However, as the negatively charged comb gets close to the tissue paper, electrons are repelled in the tissue paper and protons are left behind. This causes an electrical attraction between the two objects. The same thing happens with the balloon and the pieces of foam. Here they have the little negative signs to show you the different charges. So, today we're going to talk about the electroscope. This is an interesting instrument for detecting static electricity. One type of electroscope shown here consists of two thin metal leaves suspended from a metal hook. You have the opportunity today to make one after you watch the recording. When an object with a positive charge gets close to the hook, electrons flow into the hook from the leaves, and we'll turn this little thing on so you can watch it. And when an object has a negative charge, the electrons in the hook flow down the leaves. In either case, the leaves have the same charge, so they repel each other. So watch it again. When they're done, she puts their finger on there to neutralize the charge. So you'll see your little finger go there, and it resets it. And that's how you can do it with your experiment too. So what happens to electric charges? Well, in a static electricity system, electric charges build up but do not move. When the electric charges move or discharge, an electric current is created. Have you ever felt a shock after you walked across a rug and then touched a doorknob? That is an example of an electrical current. As you move your feet across the carpet, static electricity is transferred to your body. When you touch the doorknob, you are transferring the electricity charged in an electrical current. Lightning works in the similar way. Static electric charges build up in the clouds and on the ground. It's not just in the clouds. Eventually, the negative charge of a cloud moves from the sky to the positively charged ground, and vice versa. When this happens, you see a flash of bright white. You will learn more about electrical currents in lessons to come. This is your great chance. This is a fun activity, and I'll be showing you in class today how to do it. An electroscope is an instrument used to detect the presence of static electricity. It often consists of two metal leaves suspended from a metal hook. You really don't need much to build this. A balloon. It doesn't even have to be, find an old balloon. A glass, some aluminum foil, a piece of paper or an index card, paper clip, a ruler, metric. It has to be in a metric ruler, or you can measure it the other way too, but to be accurate, you would use a metric ruler and scissors. So we're going to end this recording right about now. You can gather those materials, get your student pages out, and build your own. When you're finished with that, make sure you do your lesson review. We will also be going over this in class. We have these terms, and you will need to be able to know what they mean by inserting them into these sentences. This is also a really great activity that you should save to prepare you for the end of unit test, because these words and definitions are right here for you. Well, I hope you guys are ready. Once you have done your review, you will be ready to take the lesson assessment and mark this lesson complete. Have a great day. Goodbye.